All right. It's back.
Wait, real quick. Do you watch football?
I have in the past. I haven't in the last.
You don't have like a team or anything?
I used to, but then I realized I really didn't care. I got nothing out of cheering for them. There's no financial gain unless I risk money on it. I gained nothing from it.
I was gonna say what you're.
I used to cheer for the Niners though.
Hey, that's right. Ooh.
As of now, I put the readers.
Cowboy.
I love the Cowboys.
Jets.
Packers. I go for this.
He said over here.
Well, so they go on that kids.
We have already.
He's at the age where, you know, Brett Favre was super popular and leading the team to victories. And so, like most young football fans, grow to like the teams that win. My brother, he's a fucking Bears fan. Bears fan.
A Bears fan.
Yeah, in California. He doesn't have it easy.
He doesn't have any.
Bears never go. They never go to the bowl.
Yeah, Bears suck.
But he's been a loyal Bears fan since he was like 12.
Yeah, I'll give him that. That's probably.
That, yeah, he's got loyalty, and they were, I don't know if they did well when he was like a kid, the 1 year they might have ever done well. Before, you know, refrigerator Perry and all that. All right, so we were doing systems of equations. This is math 207. Do I have record hit?
Yeah, you said recording in progress.
It does, I see the recording thing, thanks. All right, so we're on chapter 10. Let's actually do some. Ariana's done fucking with my schedule today. Let's get some math in. We looked at addition method for, this was system of equations. And this worked well when we had like 2x plus 3y equals 5 and 2x, or let's say 3x minus 3y equals, oh fuck it, let's go with 10. And so when we did this, we would add, we wanted the coefficients or the numbers in front to be equal and opposite. In this case, they are. And we add them up and we get 5x equals 15. We divide by 5 and we get x equals 3. And we can take that, plug that back in to one of these equations. I'll plug it into the top one. So you get 6 plus 3y equals 5. Subtract 6. 3y equals -1. And y equals -1/3. When I divide by 3. So the point is 3 and -1/3. Notice there is a fraction in the answer, but it doesn't show up till the end, which is good. So that was the addition method. We also had the substitution method. Different color, let's go different color. Did we do the substitution method? Did I get through that? I don't know that I did.
You did. Wait.
Let me check my lecture notes. That's the wrong class. Let's go find the real lecture notes. Monday. There you are. No, we only did the adding method. Okay. So what we're doing today is the substitution method. I get 4. 2x plus y equals 4. And maybe 5x plus y equals 13. Let's solve it the way we know how to first, the addition method. So you see the answer, and then I'll show you the substitution. So the addition method, we need to have equal and opposite coefficients. I think the easiest one to do this on is y, because we just need to multiply by a negative number, -1. So I'm going to multiply this one by -1. And I'll write it below. And I get -2x minus y equals -4. I add these together and I get 3x equals 9. We divide by 3, we get x equals 3. And we take it, we plug back into one of the equations. I've got 5 times 3 plus y equals 13. So 15 plus y equals 13. And we subtract the 15. And we get y equals -2. So we had the point 3, -2.
Let's.
That's a coordinate. X is 3, y equals -2. It's a parentheses and a comma.
Look, no, -1.
You see her? She's fucking leaning.
Stop. Wait, but for real, like, that just like.
What looks like scribbles?
The 4.
Oh, that's a 4?
That is a 4. Yeah, I wrote over it. You're back there. If you're that far back, let me know when I lose you. Yeah, that's a 4. Damn, I like didn't have her the whole fucking problem. Like, let me know to stop, like, because. Yeah, seriously, just tell me to slow down in the future. Seriously, because now we're waiting, it takes longer now, I would wait for you. And I didn't have you the whole way. Thankfully, this is stuff we already taught before, but that doesn't mean anything, because I know you didn't do any homework between Monday and now. I don't even need to look. I know you're a slacker. Shall we look?
No.
Shall we look at the last chapters? You know, the ones that you should have done the homework for before the midterm. And look at that, see if you're a slacker.
Yeah, this, a subject, that's one.
It's even harder when you don't do the homework. It's how? You see me twice a week, and I know I am 100% certain when you leave here, you talk about me. You know how I know? Have you ever had a teacher that farted and asked you, does that make you hungry? I know you told someone else about it. I know you told someone else, the foul ass teacher that you have, you talked about me. So the math is you thought about me outside of class.
Oh, damn.
This motherfucker farts and says it smells like roses. It says it's like bacon.
Now you should.
All right, so I'm going to rewrite those same equations and we're going to do the substitution method. So the way the substitution method works is. Solve one of these for a variable. And substitute or plug it into the other equation. So I'm going to do that here. I'm going to subtract 2x from both sides. And to get y equals negative 2x plus 4.
Yeah.
And then I'm going to take that value for y and I'm going to plug it in where y is in the other equation. This was where y was, and I'm going to take it, I'm going to plug it in, and you definitely want to use parentheses. Because if there's a multiplier there, you need to have the multiplier. So now I can add these up. I've got 5x minus 2x plus 4 equals 13. This goes to 3x. And subtract by 4. My 4. Divide by 3, and I get x equals 3. I plug that into my other equation. And I get y equals negative 2. Or negative, that was that changed it right there. 2. And again, I have the point 3 negative 2.
So are you still doing tutoring?
Yeah, and Sundays. I am. Yep. Caldwell and Demery.
Yeah.
Starbucks at Toronto Tahoe does, I know. What? 8 to 11.
That is.
I don't want to waste up my fucking day on the weekend. That's like movie going time and doing shit with my family. You what? When do you get up on the weekends?
I'll be getting home like at 5 in the morning sometime. On the weekend.
Don't party that fucking late. I know it's partying, and now it's not, you're working the graveyard shift. Don't do that.
Did everywhere.
So, let's do some more substitution method problems.
Oh, hell no.
This is one of the first problems we had in the other section. On Monday. No, I didn't. I changed the numbers when I did it. I think I changed it to 8 and 2. Oh well. Here it's already set up for you for an easy substitution. Go ahead and give this a try. See what you come up with. We're solving these together, remember.
So. Would it be 2x plus y? Equals 1.
What did you do? I didn't hear what you said, try it again.
2x. Plus 2y equals 1.
No. So we wanna replace one letter in one equation with the value from the other. We already have this one written as y. So like this part and this part are equal. And we have a y right there. So instead of leaving y there, we can take and put that in there. It's like having a bunch of socks. They're all the same fucking color, white socks. The pair that it came with doesn't need to stay connected as long as they are equal. Or unless you're one of those freaks that likes to wear multicolored socks. Let's see your socks, Ariana. I bet you do. I bet you have a fucking red sock and a blue sock. That doesn't mean you don't have socks on.
Oh, they have to be matching.
Okay, good. There are people that like mismatched socks. I'm like, what's wrong with you? Now, you know what's awesome? Sandals and flip flops. That's the fucking way to go right there.
Maybe like.
My wife fucking hides my sandals come summertime. Cause she fucking thinks it's fucking terrible. But I'm like, your feet get hot in the summer wearing shoes. But if you don't have socks on, they get all fucking filthy. So if you have socks and sandals on, you get a nice airflow, but you don't get all fucking dirty feet. What?
You can have your socks with your socks.
What's the difference between a slide and a fucking flip flop?
The little thing they go to.
Yeah.
Slide.
Any kind of open foot thing. Yes, those, yeah, but still, I do not like wearing slides outside the house. I'd rather wear a sandal where it fucking like it wraps around the back, there's like a fucking Velcro thing. You've never seen a fucking sandal?
Like the watches.
I like them. They don't fall off, you don't have anything between your fucking toes. Like, alright, so if we take this y equals x plus 4, these two things are the same value, so I can take this thing and get rid of it and plug this in. If I do, I have that. Does that make sense what I did there? All right, so picture these two as a pair of socks. They look different, but they're not. They're the same sock because they're equal. The equal tells me the same sock. So I'm just reaching in my sock drawer. I don't want this sock. I'm going to use this sock. So I can replace this because they're equal. These two things mean the same thing. Like if I had 2 equals 2 here or y equals 2 here, we do this all the time when we're solving. We just did this when we solved. When y equals 2, we replace the 2 in. But here it's not 2. We don't know what it is yet, but we can still plug it in. That's the idea of what's going on here. Does that make sense?
Yeah.
Okay. So this gives us 2x plus 4 equals 20. We subtract 4. We divide by 2 and we get x equals 8. Now we can plug that 8 into either of the original equations. I think it fits in pretty well into that one. And I'm doing it again because x equals 8, I can swap it out and put in the 8. I need a better analogy than socks. Butter and margarine, not really, it's not good match now. This method sucks. This method is terrible. If one of the variables doesn't have a coefficient of 1. So for example, we're not going to resolve this because we did this on Monday. When you have something like 4x minus 3y equals 23 and 5x plus 2y equals -4. I don't have a coefficient of 1. Substitution sucks ass. It's terrible. Because if I want to get something by itself, I'm going to have to divide by the coefficient and I'm going to get fractions. Like here, if I subtracted 5x, I get 2y equals -5x minus 4. If I divide by 2, I get y equals -5/2 x minus 2. Working with fractions sucks. So this method, it works, it does work. But when a coefficient is 1, or there's no coefficients that are 1, it's a crappy one to use. I'll give you guys another one. And we'll do it both ways. We'll do addition and we'll do substitution. In fact, you try doing it both ways. Try doing this with addition and substitution. If you did it correctly, you're gonna get 4, 3. Did anyone get that?
Yeah, I know.
Anyone online?
I did not get that.
Okay. So, let's talk about what we can do to do it. Let's do the addition method first. So what we do is we add the equations together. Y and negative y are already opposite, so when I add them together, the y's go away. And I have 2x there, and 7 plus 1 is 8. And if I divide by 2, I get x equals 4. I'm going to plug that into the top equation. 4 plus y equals 7. And we'll subtract 4. And we'll get y equals 3. I think the addition method is easier in every way, shape, or form. Other than when it's just when it's already given as one of the letters equals to the others. The only time it's not easy is when all the numbers have all the letters have different numbers in front of them. But neither method is good, and at least the addition method doesn't give you fractions. At least until the end. Unless both solutions are fractions, both answers are fractions. All right, so the other way of going about doing this. I'm going to do it both ways. I'm going to solve for a different letter in each way. So you can see which way you like. Here, if I add y to each side, I get x equals 1 plus y. This x and this x are the same. So I'm going to replace the x in the top equation with its value I just got. And I'll plug this in right here as 1 plus y. And if I add the y's together, I get 1 plus 2y equals 7. I subtract 1 from both sides and I get 2y equals 6. And when I divide by 2, I get y equals 3. I can go back and plug that into either equation on the top. If I put it into the bottom one, I have x minus 3 equals 1. And I add 3 to both sides and I get x equals 4. Which is what we had up here. All right, so on the left side, I solve for x. On the right side, I'm going to solve for y. On this one, if I subtract x from both sides, I get y equals 7 minus x. And I want to plug it in for that y right there. So if I do that, I had x minus y equals 1. I'm going to put in that 7 minus x in place of that y. If I distribute this minus sign, I get x minus 7. And minus minus x is plus x. So if I add the two x's together, I got 2x minus 7 equals 1. I'll add 7 to both sides. Get 2x equals 8. And divide by 2, and I get x equals 4. I like the addition method better too. I think it's easier. The only time the addition method is not easier. I'll give you an example when everybody's ready. And I think it's just about the same difficulty. Let's say I had 2x plus y equals 4. And 5x minus 3y, let's see, equals -1. We'll do this one both ways. I'll start with the substitution method. I've got a letter that's got no number in front of it. I can easily solve this one for y if I subtract 2x from both sides. If I do, y equals -2x plus 4. And this y right here is the same as that y right there. So I can replace that y in there with -2x plus 4. So if I distribute the -3, I get -3 times -2x is 6x. And -3 times 4 is -12. You still have -1 on the right side. If I add my x's together, I have 11x minus 12 equals -1. Add 12 to both sides. And I get x equals 1.
So it looks like to be subtraction. When it's the -1 plus, or +12.
I'm doing the opposite of whatever's present.
Yeah, but I'm saying on the other side would be subtraction.
Yeah, this is the same thing as doing 12 minus 1. Then I'll take that and I'll plug that into the 2x plus y equals 4. And I get, this is 2 plus y equals 4. I subtract the 2 and I get y equals 2. So I have the point 1 comma 2. Now, if we do this the substitution method, or the addition method.
So on top of the.
Yeah. Because we solved for one variable and substituted it or plugged it into the other. Here, I need to get a matching coefficients that are opposite. I think the easiest one here to do is the y's. Because this doesn't have one. So I can multiply this, if I want to make this into a 3y, I can multiply this by 3. So 3 times 2x is 6x. 3 times y is 3y. And 4 times 3 is 12. I'm going to come over here and line it up underneath these because it's easier to do addition that way. So we can add the equations together. And the y's go away. 5x plus 6x equals 11x. And -1 plus 12 equals 11. And now we're right where we were in the other equation. Divide by 11. And x equals 1. And I can plug that into either of the original equations like I did before. And we're gonna end up getting 1, 2 again. Now, this was, the addition method's not too bad here. It's worse though if they both have the same signs, and then I gotta do like a -3. Cause then I can mess up the distributing the negative sign. The final countdown. All right, you guys ready for a little bit more different kind of stuff? Where does this show up in careers, trade skills? So word problems. Everybody's favorite. A tank holds a solution of 10% herbicide. You want to kill weeds. Another tank holds a solution of 40% herbicide. Farmer John needs 120 gallons of 20% solution. Of herbicide. How many gallons of each solution should he mix? This would be a fun problem with alcohol. You got Bacardi 151, and you got 8% beer. And you want to make a drink that's like 35% alcohol. What combination of the two do you use? I bet tea's good with alcohol in it. I haven't had alcohol in almost 3 years. I get really bad with alcohol. It's too when it's everywhere and it's cheap. Told you I like drinking cheap shit like Pop-Off and Kool-Aid. I can literally, it's cheaper than fucking buying a meal at Jack in the Box. It's cheap ass vodka.
Like those little ones?
There is like, we have some.
They have different sizes.
Yeah, you can get the gallon for like.
Yeah, you can get the gallon like Boots Co, or you can go to like almost any gas station. It's too easy for me to get smashed and not want to do my job the next day. Has everyone got this written down? All right, so we've got 2 tanks. This has got 10%, and this has got 40%. And John wants to take some of each. Let's say there's like red fluid in here. And he wants to add some red fluid. And we got blue fluid over here. And he wants to add some blue fluid over here. And when he mixes this up, he wants the mixture to be 20%. And he wants 120 gallons. Okay, so when we're doing word problems, it helps to identify what you're looking for and give it a variable. I am looking for how many gallons of each solution. So maybe I can call this A and I can call this B. Solution A and solution B. Or you can use X and Y, or you can use smiley face and frowny face. But I like using simple letters here. I know that if I add A gallons plus B gallons, Farmer John wants to end up with 120 gallons. So if I write that without the word gallons in it, I have A plus B equals 120. So right, like A is representing, A is the number of gallons of 10%. And B is the number of gallons of 40%. The way I got it written. I gotta bring the percentages into it somehow. So kind of like alcohol. You know, like when you get regular 40 or 80 proof alcohol has 40% alcohol. Only if you could separate the alcohol from the other liquid in it, only 40% of the bottles is alcohol in an 80 proof container. The same could be done here. I could like separate it out. And so like if you're separating it out, I could say the amount of solution that's actually herbicide in this one is 10% of A. Is actual herbicide. So turning the 10% into a number, that's 0.10. A. We can do the same thing with B. 40% of B should give me 0.40 B. If I add these together, I want to end up with 0.20 of my total 120 gallons.
Why is it 0.20?
Because we're going for 20%.
Oh, okay.
Now, normally I wouldn't write the zeros, but I wanted to make sure you guys could see the 10, the 40, and the 20 show up in decimal form. I would normally just write 0.1, 0.4, and 0.2. Now, I don't like working with decimals. If I multiply this by 10 everywhere, ten times 0.10 is 1. And 10 times 0.40 is 4. And since these aren't added, I only need to distribute it to one of these here. 10 times 0.2 is 2. And now that I don't have any decimals, I think it's easier to multiply now. I've got A plus 4B equals 240. Up here, I had A plus B equals 120. So what if I subtract bottom one from the top one? This is kind of like multiplying by -1 and then adding. A minus A is 0A. 4B minus B is 3B. And 240 minus 120 is 120. Now I divide. And I'm going to get B equals 40. And I will put that into one of my other equations. The easiest one to put it in is the A plus B. And if I subtract 40 here, I get A equals 120 gallons. This is also translate to problems in nursing. When you need injection solutions, a certain solution value, but you may need to cut it. I don't know the nursing terminology for it. Cutting it is a drug terminology. Never mind.
Why is it A, it's 100,
That should be
why
80.
is A, it's 120, 120 minus 40?
80, my bad, thank you.
Oh.
Good catch. It shows up in electricity. Does anyone need this up longer? Maybe you're an electrician or something like that. Shows up in a couple different ways. Capacitors add a certain way, resistors add a certain way. Voltage. If I have two dry cells connected in series. Two dry cells are connected in series where each has a different internal resistance. The total internal resistance is 0.12 ohms. The difference between the two internal resistances is 0.02 ohms. what are the two resistances? What are the internal resistances of the two dry cells? All right, so I'm looking for two different resistances, and I don't know what they are, but I'm going to call them X and Y. X will be the first one. And Y will be the second one. This tells me here the total internal resistance is 12 or 0.12 ohms. What does total mean? All of it. What does all of it mean in math?
Altogether.
Again, what kind of like operation is that? Adding. So the total of the two resistances, X plus Y, equals 0.12. What does difference mean? It means subtraction, right? And do X minus Y equals 0.02. So what should I do here? I've got two equations. I got two variables. What's the best approach?
Addition method.
I think the addition method is a great approach. Let's do that. What happens if I add these two together? What do I get?
X equals 0.14.
Close.
2x.
It's 2x. Because we got two x's here. We got to add them both together. So I divide by 2. And I get x equals 0.07. And that's in ohms. Because that's what resistance is measured in. I can go and take that in and plug that into one of the initial equations. And we'll subtract to get y by itself. So those are my two resistances. Does it match up? If I add x plus y, that's 0.07 plus 0.05. I add them up and I get 0.12. So that means it meets this first equation. If I do x minus y, I should get 0.02. 0.07 minus 0.05. That does equal 0.02, so it matches that equation. The answer matches in both equations. So it's 7 ohms for one and 5 ohms for the other. Ready for one more? All right.
Like,
Really? No shit. You're an anomaly. You're an exception. Most people see word problems and go, nope, that's too much work. I think it helps to go, why am I doing this? If you start with a word problem, you at least know why the fuck you're doing it. It's not just like I'm doing math for the sake of doing math. Believe me, I've cut out content that's in the book that I can't see where you would use it. There's gonna be content in the next chapter. I don't know where engineers use it. Fucking not gonna give it, I definitely don't know where you guys are gonna use it. I fucking just chopped that shit out. And I had to, Bertha fucking started chapter 11 for fucking 10 seconds on the homework. And so as soon as the student starts the homework, it locks it down so I can't change shit. She didn't do any homework. She didn't do anything in chapter 11. I think she just clicked on it on accident. So
Sorry.
it's okay, I deleted your shit. I deleted your shit so that it said should have no students that worked on it. And so that I could go in and delete problems from the set that are just like, there's no point in you learning this. So the content I gave you, there's a purpose. It may not always be obvious. If you guys like word problems though, I will try to fit them in more along the way. This chapter is set up to do the word problems at the end. It's actually 10 point, if you'd like to look at the lecture or the book thing in my math lab, 10.4 is like, I think it's even called word problems or applications. Applications is the word they like. So let's say a construction job needs a mixture of fieldstone. I don't know what the fuck fieldstone is. I got this problem from the book. This is apparently something construction workers do. We teach construction here. And the fieldstone is comprised of two different kinds of rocks. Or stones. Ariana buys 27 tons of stone. Of fieldstone. For $954. One of the stone types or one of the rocks is $38 per ton. And the other is $32 per ton. How many tons of each did she get? Are in the mixture. Like they sell it, the place sells it all three ways, let's assume. And you just buy the field stone the way it is. And if you wanted a different ratio of the two different types of stones, you could buy it separately, but she's just like, fuck it, I'm buying this is easier. I don't want to do no math. But then her boss says, well, how much of each was in there? Maybe I wanted more of the other. So she has to calculate. Bless you. All right, so. What I'm looking for is how many tons of each that she got. So tons of rock 1. And tons of rock 2 are what I need to assign variables to. You guys want to have any preference?
So I see different numbers.
Oh, we'll do subtract where? Not difference, it says different.
Yeah.
That's just telling me there's two different, there's two different types. What should I call them? I don't know how much of each, so I gotta give it a variable. You want R? What about the other one?
A.
A, okay. So you bought 27 tons. And we know part of it is made up of rock R and part of it is made up of rock A. So maybe you bought, and you don't know how much is each, R plus A equals 27. These are all in terms of the tons or the weight. The other one we need is the price. We got information on price. So let's say, in fact, they give it to us. Let's say R is the $38 one. So if I have 1 ton of R, it's $38. If I have 2 tons of R, it's 2 times 38, which is $76. If I buy 3 tons, I'm leading to the idea of what we're going to do here. 3 tons of R would be 3 times 38. And that is $114. I don't know how many she bought though. How much is R tons of R? What have I been doing each of these steps? I've been multiplying the price by the total number of tons, right? So this should be $38 times R. That should be the total amount spent on rock R. We could do the same thing with the A. Its cost is $32. We were told Ariana spends $954. Before we solve, it's kind of helpful to point out, like I should have done this on the other ones. This entire equation is related to weight. The tons here, R's in terms of tons, A's in terms of tons. This entire equation here is all related to price. When we did it with the tank with the herbicide, one of the equations was number of gallons and the other was percentage of solution. The stuff across in every single thing has to be the same kind of unit. So it can kind of help you figure out what goes together. Here, we can do the addition method. It's the harder method though. Because I'm going to have to multiply one of these by either -38 or -32. And I don't want to do that with the 27. If I add it up, I've got big numbers there. And I don't want to add up and have a bunch of big numbers. So maybe let's substitute. If I subtract R from both sides, I get A equals 27 minus R. And I'm going to take that and stick that in right where the A is. In the other equation. Capital. So if I distribute this, 32 times 27 equals 864. And 32 times negative R is negative 32R. So if I add the R's together, I've got 6R. And I can subtract the 864. I think that's 90. Is that 90 area? Let's see, you done it. Hurry the fuck up. She's like, I don't believe you that they're just.
Yeah,
That's not you. So if I divide by 6, I get R equals 15. 15 tons of that one. I've got A equals 27 minus R. So let's just put in the 15. 27 minus 15 is 12. So the $38 rock, I have 15 tons. And the $32 rock, I have 12 tons. Any questions? All right, I could start a new chapter, but I'm not going to. There's a lot going on in this chapter, and I think let's just call it a wrap for the day. Next chapter has a lot of stuff that's not too bad in and of itself, but there's a lot of different shit. Fucking out the door already. Look up. You just fucking waiting. You guys get online?
Yeah, I'm okay.
All right. I will see you guys on Monday.
Thank you, bye.
Uh-huh.